The plan for this lesson is to go over several plots that summarize key statistics of the data. First, we will explain statistical terms such as quantiles, quartiles, and percentiles. Then we will move to the visualization part. Let me start by saying that these concepts, quantiles, quartiles, and percentiles, are typically explained in textbooks in the context of a normal distribution because it's a familiar and easy to explain. However, these terms apply to any data distribution. Quantiles represents a quantity or points taken at regular intervals in a distribution. So it's going to divide this distribution to equal size intervals. And once we divide the distribution into equal size intervals, we can make statements about what happens in the middle, far right, far end, or any interesting area. In this visualization, suppose we measured the height of 20 individuals and sorted them ascendingly. So this individual highlighted in the light blue represents the 80 percentile, which means they are taller than 80% of this population. The box plot visualizes the dispersion of the data presented by the 5-number summary. What are these numbers? The minimum, Q1 or the 25th percentile, the median or Q2 or the 50th percentile, Q3 or the 70th percentile, and the maximum. The interquartile range represents the distance between Q1 and Q3. There are two whiskers connecting Q1 and minimum and Q3 and maximum. The median is presented by a line inside the box. Any point that is higher or lower than 1.5 IQR is considered an outlier and will be plotted individually. Histograms are used to plot data frequencies, and they are great for showing data distributions. The interval in a histogram can be fixed width or a variable width, and they can also be more expressive than box plots. So we have histogram 1 and histogram 2. They share the same 5-number summary, but they show different distributions. Bar charts are good for comparing variables. The y-axis represents the categories and the x-axis represents the frequencies. So in this example, we compare COVID cases in 2 counties in 3 months, which is something we can't do in a histogram. Quantile plots are interesting as standalone plot and can also be a stepping stone for creating the quantile plots. Let's unpack this graph. The points on the x-axis are the 4 quartiles, Q1, Q2, Q3, and Q4. The data is sorted, then plotted, which provide us with valuable insights, and these diamond-shaped points in the plot represent the unit price for product in a grocery store like Walmart. So we can observe this linear relationship between the quartiles and the unit prices, which indicates that the data might be uniformly distributed or close to a normal distribution. The key idea in the quantile plot is to compare two distributions. Let's get to the example. Suppose the x-axis represents the prices in a department store 1. Let's call it Walmart. And the y-axis represents the prices in another department store. Let's call it Target. And suppose there are like 10,000 identical items sold in both stores. So I'm going to sort them ascendingly and plot them as data points in this graph. I'm also going to show the quarters. So let's pick a data point here. If you look at the x-axis, you will get the price in Walmart. And if you look at the y-axis, you will get the price in Target. And if the data point lies on the straight line, that means the price is identical in both stores, right? So this tool allows comparing two data distributions and make statements like how the prices compare in two stores. In this application is credit card debt distributed like a normal distribution. So the key idea here is to use the data set that we have for the credit card debt as the x values and generate normal distributed values using a specific mu and sigma for the y values. And then we plot the data and try to interpret these observations. So one key observation that a credit card debt can't be negative. Also, some people have a credit card debt larger than what a normal distribution would predict. So anything above the straight line, it means we have more credit card debt than what we expected. And another interesting observation is the credit card debt has heavy tail distribution because it goes on and on. Data visualization is an important tool to understand, interpret, and communicate complex data. It transforms abstract numbers and statistics to visualizations that provide insights and inform decisions. So from now until the end of the slides, we will examine different types of plots. A scatter plot visualizes data points in the space. It can be two-dimensional, three-dimensional. It can show clusters, patterns, and trends, such as correlation. The first plot here shows a positively correlated relationship. As you can see, when the x values increase, the y values also increase. The middle plot is negatively correlated. When the x values increase, the y values decrease. The third plot is actually interesting. The left side is positively correlated and the right side is negatively correlated. In this example, the data is uncorrelated because when the x values increase, some y values go up and other y values go down. Pixel-oriented plots are used to visualize high-dimensional data sets, and they can be very useful in visual analysis and pattern recognition. So processing the first dimension is very important because it's going to shape the whole process. For example, we may sort individuals by their income and assign the darker colors to those with high incomes and white to the lowest. Now when we move to the second dimension, we start to see correlation. Who are at the highest income, they also have the highest credit, and the one with lowest income also have the lowest credit. So there is a positive correlation here. Processing the third dimension reveals something very interesting, that those who make the most transactions and purchases are not the richest or the poorest, are actually the ones with the middle income. Finally, there is no correlation once we get to the age because it looks like we have pixels with different colors all over the place. Next, we will cover a number of geometric projection techniques such as scatter plots and landscapes. This graph shows a 3D scatter plot which helps showing the relationships between the attributes, identifying clusters, patterns, and outliers. Scatter plot matrices explore the relationships between pairs of attributes in a high-dimensional dataset. In this example, we have the iris dataset that consists of 4 attributes, and we can see the scatter plot for each pair, and we can look for patterns and correlations. Landscapes provide an intuitive and visually engaging way to explore and analyze complex dataset. So the dataset will be transformed into a 2-dimensional spatial representation where the features are going to represent something in this topology. It can be mountains or valleys or specific color code. Parallel coordinates plots provide a comprehensive view of the dataset structure. So each attribute in this dataset is going to be presented as an axis, and each example will be presented using those diagonal lines. In this example, we have a visualization for the iris dataset. So I can see each attribute, sepal width, sepal length, petal width, petal length, have an axis in this plot. And each example from each species is color-coded and presented by those diagonal lines. And these parallel coordinates plots can be 2-dimensional and also 3 dimensions. The key idea behind icon-based visualization techniques is to use the attributes values in a dataset to create features that will compose an icon in a certain shape and then use those to visualize the whole dataset. Some of the examples are churn of faces and stick figures. Hierarchical visualization techniques use partitioning to show the different layers, views, and level of details in a multidimensional dataset. An example here is the tree map. News maps are tree-based data structures for visualizing news, and as you can see, the most trending headlines are shown in big fonts here. Graph visualizations show complex network structures such as information and social networks. Finally, tag clouds highlights higher frequency words in relatively bigger fonts and less frequent words in smaller fonts. In summary, we covered statistical terms such as quantiles, quartiles, and percentiles, and discussed data visualization techniques.